Hello YouTube. Today I thought I'd give you a tutorial on converting IP addresses to binary and vice versa. This is an essential part of networking when you start to implement VLSM or Variable Length Subnet Mask and CIDR, Classless Inter-Domain Routing. To briefly describe how to convert traditional IP addresses or IPv4 addresses to binary, there are a few things to know about how the addresses work. IPv4 addresses contain 32 bits versus the new IPv6, which contains 128 bits. These 32 bits are broken down into 4 groups, called octets. Each octet consists of 8 bits. We will have heavy use of the powers of 2, so brush up on your math skills, kids. If math isn't your thing, don't worry. I promise it'll get easier, and the more you practice with it, you'll get better. Something I feel that helps me along with converting addresses to binary is to write down the powers of 2 starting at 128 and work my way down to 1. We got 128, 64, 32, 16, 8, 4, 2, and 1. So now let's start with an example. Let's take the IP address 192.168.1.0. Now what we're going to do is look at our chart, and we're going to find out what numbers will equal up to 192. The first bit we will turn on using a 1. Remember, this is binary, so bits are turned off by a 1 or a 0. So we'll turn on 128, and we need to find out what else is equal up to 192, which is 64. So we'll turn that bit on. Now that we have 192, the rest of the bits will be turned off. And now you have your first octet. Be 11000000, and we separate each octet by a decimal. Now we move on to our second octet. We need 168. So we'll use our first octet and turn it on to get 128. And we know that 128 plus 64 is 192 from the previous octet, so we'll leave that bit turned off by giving it a 0. Now if we add 128 and 32, that gives us 160. So we will turn that bit on, as well as turning on the 8-bit, which will equal up to 168. The rest of the bits will be turned off. There you have the second octet, 10101000. And again, we use a decimal to separate the octet. And we move over to the third octet, which is just a 1. So in this case, we will turn all bits off except for the last bit, which is a 1. It will be 00000001. And now the last octet is a 0, so all bits will be turned off. And there you have your first IP address converted to binary. Let's try a second example. Let's try 10.1.10.255. Since our first 4 bits are higher than 10, we will leave these 4 bits off. And now we have an 8, and 2 adds up to 10, so we will leave 8 and 2 on. So your first octet is 00001010. And from a previous example, we know that 1 is just the last bit, so we'll do 7 zeros and a 1. And from the first octet, we will just copy over because it's the same octet. Now our last octet is 255. This could possibly be a broadcast address. So all of our bits added together equals 255. So we will turn all 8 bits on. And there you have your second IP address converted to binary. Now let's try something different. Let's try going from a binary address to an IP address. This really isn't any more difficult, it's just working in reverse. Alright, here's our example. So now we just need to add up each bit and find out what we get out of it. The first bit is on, which is 128, and then 32, then 8, and 4. If we add these up, we get 172. Now our second octet, we add up and we should get, see here, the 16-bit and the 4-bit, so we will get 20. And from our previous example, we know the last bit is a 1, so it'll be 172.20.1. And the last octet looks like the 8 and the 2 octet. Sorry, the 8 and the 2 bit is on, so that will give us 10. So there's our IP address, 172.20.1.10, given to us from binary. Hopefully this gives you a little more information on how to convert IP addresses over to binary and vice versa. And like I said, keep practicing with it, and I promise you'll get better. In the next video, I will try to get you some VLSM and CIDR notation. Thanks for watching.